And here we have our third and final method for finding volumes of rotation. This one is called the shell method. So suppose that we have a shape like this. Here's the little shaded area, and then we're going to rotate that around an axis. Well, before I even rotate this one around an axis, I'm going to put the representative rectangle. So the representative rectangle cannot go from the same function to itself, so it cannot go horizontal. It has to be vertical. So this is going to be the representative rectangle. And so this little width right here is delta x. And now for the fun part, rotate this about the y-axis. So you'll notice something a little bit different. In the disc in the washer, this rectangle is actually perpendicular to the axis, but in the shell method, these two are actually parallel to each other. So that's a major difference. Now when you take this little red rectangle and then you rotate it around the y-axis, around and around and around, it makes what's called a shell. I happen to have an example right here. Here's a tin can or aluminum can, whatever it's made out of. It's empty. I washed it. I cut the top and the bottom off. That is a shell. So now we need to find the volume of this metal. It's real. So how do you find the volume of this metal? So for one thing, you need the radius. So go from the center out to the middle of the metal. So that's called the radius. And then the thickness of this metal, that is delta x. So this delta x right here, when it got rotated around, that's this thickness. And then also we would need to know the height. Not the height of this actual can, but the height of the function. So the volume of one particular shell is going to be 2 pi times the radius times the height and times delta x. So that would be the formula for finding how much metal is this made out of. Okay, now that would just be that one shell. Then you need to integrate from the beginning to the end. So in general, it's going to be integrate, and let's say this is from A to B to just make up general numbers. And then it would be 2 pi times the radius. So the radius is measured from the middle out to the middle of this rectangle. So when I had the can right here, the middle, that would be the origin. So, or excuse me, that would be the y-axis. And you measure from the y-axis over to the middle of this metal part. So the radius is measured from the y-axis over to the middle of this rectangle. That is the r. And then the height is the height of this function. So that would be the function f of x. So the general formula is 2 pi times the radius. The way that this picture is set up, this radius right here, well, that would be whatever x equals. Going from here over to here, that would be what x equals. And then the height, that would be the function. And then when you do the integral, the delta x becomes dx. Okay, now let's do an example. So what's an example that would create a function like this? The example is x times parentheses, x minus 1 gets squared on the interval from 0 to 1. And just in case you don't believe me, here's the y equals x times x minus 1 squared. And then I change the window to go on the x-axis from 0 to 1. And it's a very short function, so the y value is just 0 to a 0.25. And then it makes that type of graph. So it's about like that. This is 0, this is 1. And then the representative rectangle would go like this. And this one is going to be rotate about the y-axis. And so the setup for the integral is going to be integrate from 0 to 1, and then it's going to be 2 pi. And so the radius is measured from here to here, and that is what x equals. Because if you're going from 0 over to where this rectangle is, well, x is ranging between 0 and 1, so at any point like this randomly chosen point right here, it's just whatever x equals. So the radius is equal to x. And then the height will just be the function. And then dx. So in order to actually integrate this one thing I could do is factor out 2 pi. And then this would be x squared. And then go ahead and square this binomial, which means it's going to have x squared minus 2x plus 1. And then continuing, so that's going to be 2 pi times the integral. And then go ahead and distribute this x squared. So it would have x to the 4th minus 2x cubed plus x squared. And now we're ready to find the antiderivatives. So for this one, it's going to be x to the 5th over 5. This one would be x to the 4 over 4. And this last one would be x cubed over 3. And then evaluate that from 0 to 1. So substituting 1 means that it's just going to be, this will be 1/5. This will be 2/4 or minus a half. And then plus a third. And when you substitute 0, it's going to contribute 0 to the answer. So how much is 1/5 minus 1/2 plus 1/3? It's 1/30th. So then it will be 2 pi times 1/30th. And of course the answer is small because that was such a short function. So let's see, when you reduce, it's going to be pi over 15. Now I'm just going to, before I go on to other examples, I'm just going to do a real quick recap of the 3 different methods. So there's the disk method, the washer method, and the shell method. And usually it does not tell you use such and such method. It's usually up to you to determine. So with the disk method, that would be if the shape was like this. There's no gap between the x-axis and the shape. And then if you're going to rotate around the x-axis, that's a good time to use the disk method. So when you have the representative rectangle and you rotate it around the x-axis, then it makes a disk. Look, I even got one right here. So disk, that would be like a quarter. So when you rotate that around, it looks like one of these. And then you just add up all of those little quarters. So the volume is going to be integrate pi r squared dx. And the radius is measured from the axis of rotation to the object. So that means that the r is equal to the function. Now, what about the washer method? So that would be if you have one function like this and another function like this, and let's say they intersect at x equals a and x equals b, and then this is the region being talked about, then there's this gap or this hole. So if you were to take the representative rectangle right here, and then rotate that about the x-axis, then it's got a hole in the middle. So instead of looking like a disc, it looks like a washer. Went all the way out into the garage to get that for you. So it would be like this, and then there would be the hole in it. So for this one, you need to measure from the axis of rotation up to the top function, and then that's going to be the big R. Then measure from the axis of rotation to the bottom function, and that's going to be the little r. And then the general formula is integrate pi, and then it is the big R gets squared minus the small r gets squared. And in this case, the limits would go from a to b. I guess I could have called this one also from a to b. So in both of these, the representative rectangle is perpendicular to the axis of rotation. Even though it's not touching it, this is still going vertical and this is going horizontal, so those two are perpendicular. And then the one that's different is the shell method. So that would be if you have a shape like this, and then we're going to rotate that around the y-axis. So then the representative rectangle in this case is parallel to the axis of rotation. And the general formula is you integrate 2 pi times the radius times the height and then dx. And then x can go from a to b again. The way that I look at this dx and the a to the b is that for this rectangle to cover this whole area, it would need to start over here at a, and then just like the x-axis, it's going to move to the right. So then it's going to be here and here and here and here until it eventually gets over here to b. And then all of those rectangles will cover the whole area. So for this one, the radius has to go from the axis out to the middle of this rectangle, so that's the radius. And then the height is going to be the function. So now what we're going to do for the next couple of examples is just figure out which method it is and then set up the integral. So practice basically with this. So for example number 2, we've got a parabola and an upside down parabola. Also x equals 0 and x equals 1. So y equals x squared is a parabola that's going up like this. And I don't need to draw this side because it doesn't say anything about x being negative, just x being positive. So from 0 to 1, which means that this y value right here is 1. And then this one is an upside down parabola that got shifted up by 2. So it got shifted up by 2, and then it's an upside down parabola. And by the time you get to x equals 1 for this one, the y value is going to be 2 minus 1, so they meet right there. Okay, then the next fun part. Rotate this shape around x equals 2. So go over to x equals 2, and then I'll just put a line right here, and then we're rotating it around this axis. Well, the first thing to do is, when you're looking at this area, is decide how the rectangle should go. So if you put the rectangle horizontal, that means we're going to have to do two integrals. One integral when it goes across and hits this parabola, and a second integral when it goes across and hits this parabola. That is going to double our work. So instead, make the rectangle go vertical. That way, it's always going from the top parabola to the bottom parabola. And we don't have to change or do two integrals. So we've got the rectangle parallel to the axis of rotation, and there's only one method that does that. We're going to use the shell method. So I always write down what the method is, and then just to remind myself, that means integrate 2 pi times the radius times the height and dx. So this one's going to be integrate 2 pi, and then for the radius. So the radius has to go from the axis of rotation over to the middle of this rectangle. So this is the radius. And since we're dealing with x's, I cannot put the letter r in here. I need to put something with x. Well, just like on that last example, if you go from 0 out to here, so this bit right here, that's x. But we don't want that side, we want the opposite side. So the opposite side, this is going from 2 over to x. So the length of this, you just take the number on the right minus the number on the left. So the length of this gap, or in other words r, is equal to 2 minus x. And then for the height, well, the height is actually going from this parabola to this parabola. So you need to take the top one minus the bottom one. So the top one is 2 minus x squared, and then minus the bottom one is x squared, and then that's the height. And then dx. And x in this case is going from 0 to 1. So I know I said I was only going to set it up, but leaving this the way that it is, it just bothers me. So I just need to clean up that algebra just a little bit. So it would be 2 minus x times 2 minus 2x squares. And then that one is set up. If you're actually going to integrate it, then go ahead and multiply all this out, combine like terms, and then integrate each one individually. And then for example number 3, so take a look at the sine function on the interval from 0 to pi. And then we're going to do 3 parts. So take that region and then rotate about the line y equals 0. So looking at sine from 0 to pi, it looks like this. It goes up to a height of 1. So this is the region that we're talking about. And then this right here, y equals 0, that means the x-axis. So rotate this about the x-axis. With this picture right here, I cannot have the rectangle going sideways because it can't touch the same function on both sides. So it must be that the rectangle is going this direction or vertically. And these two are now perpendicular, and there's no gap, So that means that we're using the disk method. And that means that we're integrating pi r squared dx. And with the disk method, the r goes from the axis of rotation to the end of the rectangle. So that means that the radius is equal to sine of x. So for this one, the setup would be integrate pi, and then the radius has to be squared. So that means that sine has to be squared. And then x is going from 0 to pi. Okay, like I said, we're just doing the setup. If you were going to integrate this one, then you need to use the trig identity. Sine squared equals 1 minus cosine of 2x all over 2. Hey look, double pi. Part B, take the same shape, but this time rotate it about the line y equals -1. So it's the same shape from 0 to pi. Good old sine graph. Looks something like that. Slightly shade the area for dramatic effect. Then what about y equals -1? So down here is where y equals -1. And if you draw a line straight across and use a red pen, that means it's going to be rotated around that line. And then this has a gap in it. So that means we're going to be using the washer method. Cha-ching! Washer time. So the representative rectangle goes like this. So it's perpendicular to the axis. It doesn't have to hit the axis, but its direction is perpendicular. So that means that we're using washer method. And the formula for that is pi, and then the big radius gets squared minus the small radius gets squared, and dx. So for the big radius, we need to go from the axis of rotation all the way up to the top of this, which is right there. So what's the length of this big R? Well, if you go from here to there, that's sine of x. That's how tall that rectangle is. It's sine of x. Then this is a gap of an extra 1. So it's actually going to be a length of sine of x plus 1. Because we're talking about the length of this. Or the other way to look at it is, if you want to find the length of something, you take the top number minus the bottom number. So the top one would be sine, and then minus a -1 means that should be a +1. Then for the small radius, so that goes from the axis of rotation to the bottom of the rectangle. And the length of this is just 1. Oops, I forgot to put the little r. Okay, so for the setup, it'll be integrate pi, and then this capital R needs to be squared. So the pi has to be times everything. And then I need extra parenthesis for sine of x plus 1 has to be squared. Minus the little r squared, so minus 1 squared. And then it's going to be dx with x going from 0 to pi. Hey look, double pi's. Now we're going to take the same shape and for part C, rotate it in a different way. So this is still example number 3, part C. And then rotate about x equals 2. So here's the sine graph from 0 to pi. It goes up to a height of 1, dramatic shading right there. And then rotate about, that was not a good choice. Who said that? X equals 2 is right here in the middle of the picture. I meant to say x equals 12. There we go. So go over here to 12. X equals 12 means it's a vertical line. Then make sure you use a red pen to go rotate around that. And since the rectangle has to be drawn this way, that means that the rectangle and the axis of rotation are parallel to each other. And we only have one method that covers that. That's going to be the shell method. And the general formula for that is 2 pi times the radius times the height and times dx. So the radius, you have to measure from the axis of rotation over to the middle of this rectangle. That's going to be the radius. On this side, this is a length of x, which means that on this side, it's a length of 12 minus x. And then the height, that's the height of this rectangle, and the height is equal to our original function, sine x. So integrate 2 pi. The radius is 12 minus x. The height is sine x. And then dx. And x would go from 0 to pi. And then that one is set up, so that one is done. And if you wanted to integrate this, you would need to distribute and have 12 times sine of x, and then also minus x times sine of x. And then in order to integrate x times sine of x, you need to wait till math 3b. Okay, for those of you that stuck around for the last part of the show, let's just do one more. Sort of like when everybody else gets up at the end of the movie where the credits are going and you stay and watch and then they do funny stuff. Well, I'm going to do, well, not funny, but math stuff. How about if you have these two? So y equals the square root of x. That looks like, you know what? I think I should use a graphing calculator just to be most accurate. So we've got the square root of x, and x is squared. And then window, I don't need any negatives. How about 0 to 5 and 0 to 5? So this is an infinite region, so we're not going to be talking about that. If you rotate that, it's going to create infinity, but instead this region right here. And if you take a 1 and square it, it equals 1. If you take a square root of 1, it equals 1. So they should be crossing right here where x equals 1. Also where x equals 0. So the parabola is actually the one underneath, and the square root function is the one on top, at least in that region. So if you go from 0 to 1, there is the square root function, which is actually the top function. It's going like that. And then the parabola is going like this. Sort of looks like an eye, huh? If you put a little, okay, anyway, got distracted. And then rotate about the y-axis. So let's see, which way do we put the rectangle? Well, if you put it vertical, it's going to go from the black function to the red function. That's good news, as long as it's going between two functions. If you put it horizontal, then it's going to be going from the black function to the red function. So we could actually do this one in two different ways and we would get the same answer. Imagine that. I forgot to put this part. Rotate about the y-axis. So let's see. Part A. If I make the rectangle go this way, then that means that the rectangle and the line are parallel to each other, so that would be the shell method. And so that is integrate 2 pi times the radius times the height. And actually, I didn't mention it before, but this could be dx or dy. In this picture, it's going to need to be dx because you need the little rectangle to be down here at the beginning. And then it's going to have to move to the right and move to the right, move to the right, move to the right. And what goes to the right? X. So this one is going to be dx. So for the radius, go from the axis of rotation over, and that means that r is just equal to x in this case. So this one would be integrate 2 pi times the radius, which is just x, and then the height. So the height would be the black function minus the red function. The black one was the square root, the red one was x squared. And then x is going to go from 0 to 1. Now, of course, I could multiply this out and integrate it, etc. I could also just quickly find the answer by going like this. Y equals, let me erase these now, and then it's going to be 2 pi times x times the square root of x minus x squared. And then we need to go from 0 to 1, so this goes 0 to 5, so that's good enough. And whatever the graph looks like, I don't care. I'm not really using this to graph it. I'm using this to integrate it. So then, if you go to second calculate and go down to number 7, and then our limits are 0 to 1. So the lower limit, 0. The upper limit, 1. And it says if we had done all of the work, we would get the answer 0.942. All right. Now, part B. Do the same thing, but in a different way, and hopefully we'll get the same answer. That's what we're supposed to do. So for part B, it would be, here's the square root function, here's the x squared function, and we're still rotating it about the y-axis. So it's the same shape and it's still rotated around the same place. This time it was vertical for the little rectangle, so this time it's going to be horizontal. Okay, so this rectangle is perpendicular to this line and it's got a gap. That means we need to use the washer method. So that will be integrate 2 pi, the big radius squared minus the small radius squared, and then d, this is going to have to be dy, because the rectangle at the very beginning would be way down here in this little corner, and then it would need to move up and up and up and up, and what moves up? The y-axis. Which means that on this one, we can't have functions of x, we have to have functions of y. So this one was y equals the square root of x. So we need to solve for x. So take our square both sides, and that means it's y squared. So this one is y squared. And then the same thing over here. Solve for x, so take the square root of both sides, and this one will become the square root of y. Okay. Then one other detail before I get to this is right here was x equals 1. But if you plug in a 1, if you plug in a 1 right here, or if you plug in a 1 right there, either way it's going to say y equals 1. So our limits are going to be that y goes from 0 to 1. So this little 1 is going to be when it's 0. The little rectangle that will be right here, that's when it's 1. So integrate from 0 to 1, 2 pi, and then the big radius. So it's going to go from here until it gets over to here. So that's the square root of y. Then we need to square that big radius. The small radius is when it goes from here to here, so that's y squared. And then we need to square that. So this one, I could simplify a little bit. That's going to be 2 pi. This is just going to be y minus y to the 4th. And finally, let's use the calculator to integrate this and see if we get 0.942. So when I go to graph it on the calculator does not allow me to use y's. So right here, I'm going to have to use x's. So it's 2 pi paren x minus x's to the 4th. And then graph that function. And then integrate from Did you notice what I did? Hey guys, nobody told me. On the washer method, it's not 2 pi. Let me get my eraser. On the washer method, this is just pi. Whew, that was a close one. Don't be afraid to speak up. Just tell me if I do something silly like that. The washer method is pi. Okay, let me fix it on here. Fixed. There you go. What's with that glare? Okay, then second, calculate, and number 7, integrate from 0 to 1, and it says the answer is 942. Spot on. All right. I'll talk to you again in the next section.